Okay, so today we are trying to build an AI that will play tic-tac-toe. So we're gonna go over to here, and I'm gonna not have my, I'm gonna have, wait, hold on. Okay, what is this shit? Alright. There we go. Alright, so yeah, I don't want to cut corners. I don't think I do. So I'm gonna render this out in I think I'll just have a web page, and it's just gonna have you know, a 3x3 grid, and then you'll hit like play game or next move or something, and then it'll do it. I think that makes sense. So actually, wait, let me just grab some really simple bullshit. Alright. Yeah, so let's see, what do we need in here? This is jQuery, I'll take it. Socket.io, don't need it. Call this tic-tac-toe. This is the script, we'll call it script.js. This is some bullshit. And then basically we'll have well, we can put this in a container, I guess. I don't fucking care. Whatever. I don't fucking care. Tic-tac-toe, and then we'll have div ID equals play game, and then I'll just call it like next move or something. And then we'll have like a 3x3 output where you can see I'll just literally use the table, I don't give a shit. Cell 1, cell 2, cell 3, four, 5, 6, 7, 8, 9. Okay, so there we now we have that's it. That's all we need. All right, so now we need some style, right? So let's save this as, let's go to desktop and create a folder. New folder, call it tic-tac-toe. Then we'll save this as index.html. Then we'll create a new document, and we'll have basically So basically there's something called next, and it's going to basically, I don't know, border, black solid 1 pixel border, background color can be I don't know, like just some fucking background color. And then we'll also have oh, what's it called? When the mouse goes over it and it's like a button. Cursor pointer, right? And then we'll have the table. Oh, and then for the container, just have like, there doesn't even need to be anything. Table, wait, no, TD. Oh, wait, how do you do the table borders? God damn it. Okay, wait, hold on. We'll just do this shit right here. Right here, boom, alright. Alright, and then we'll have something called rand move, which will be color red. And then AI move will be color blue, so you can see who's playing what move. And that's about it, really. So then we'll save this as style.css. Alright. So now we need script.js. So let me just quick grab something from this. I'm trying to grab this one thing. Yeah, window on load or something. Or like document ready, whatever. It's all good. So new. So document ready, we will have, well, first of all, we need when the next button is clicked, when next is clicked. It'll do a move, right? And this is where, okay, so now we gotta do all the fucking code now. So I wrote bother. Okay, sorry. Or yeah, okay, buller, okay. So save this as what's it called? Scripts.js. So we'll just do console.log hello worlds. Right? Right? Okay, there's our fucking website. Whoops, what the fuck did I just do? Can you see this? Yeah. I just closed one of them on accident. Which one? Index script style. Okay, style. Okay, I'm just gonna put all these on a website right now. So how come I can't connect to Narcissa online? I don't understand why. Cannot connect to server. Oh, here we go. I got it. Okay, so we'll create a directory called Tic-Tac-Toe. Here it is. It's uploading now to the internet. It is now uploaded, so we go to narcissa.online/tic-tac-toe. And it looks like complete shit, but it works. fucking works. It works. Why table? Because it doesn't fucking matter. That's why. It truly doesn't matter. This is just some kind of like visual interface to be able to do something in. So the table's empty. So basically, so there's some other style I forgot to do. So the other style I need to do is that the TD needs to also have like height 50 pixels, width 50 pixels. And that'll make the table actually like work. So now we're gonna upload that again. Alright, now let's check our beautiful website. There we go, now we have a tic-tac-toe board. And you know, I can actually show this on the screen, so I'll do that too. So let's add window capture, call it tic-tac-toe. Here it is, this is what we have created. And I can just cut it way the fuck down probably. You know, just show you this. This is what we got. So yeah. So now here's where all the fucking AI magic needs to happen. So first of all, we can make the random moves, right? So I think the first thing we should do is basically let's get it to just spit out random moves and pretend there's not two players, there's just one player, and every time I click the button it puts a random move. It just puts an O on like a random square, right? So it'd be kind of good if like the board is not, I don't have to reference the actual fucking physical table, I can just reference this internalized board that I'd have here. But it could be a simple one-dimensional array of 9 things, it could be. So let's think about this. Basically we just need to build some sort of, a little bit of tic-tac-toe code, right? So what do we got? We got, you click the next button, but okay, so let's initialize this fucking board, right? So var board equals, it's an array of like it could literally just be this. It could literally be this if we wanted it to be. I could do something like 0 equals none, 1 equals player 1, 2 equals player 2, right? So so now we just want to build like a random, like randomly setting one of these. So it sort of needs to check every square to see which ones are 0. So it's almost like for I equals 0, I is less than like 9 or whatever, or 8 or 9, I don't even know. I plus plus, and then it's like board I, that would give the value. So like basically it's almost like I want another it's almost like I want to have a empty list is an empty array, and then board I, if board I equals 0, then it does empty list. I want to push, is it, let's see, array push JavaScript. push. So it'd be like push I. Push I. So I'm pushing which tile it is that's empty into the list. So it goes through all of them, and then when it's done, it has an empty list of all the possible. So then basically I do like math.random. So if it was 2, then math random like rounded or floored, right? Like math.floor, math.random, something like this would give me, this would give me 1 or 0. So this is like a 2 thing. Like if it's math random times 2, would it give me 3 things? Oh fuck, I'm all confused. Fuck. Array elements are -1, 0, +1. I mean, it could be that. I don't know. Let's see. Fuck. Let's think about this. Math.random times empty list.length, right? This gives chosen move equals, but then I need a math.floor. So I pick a random number between 0 and 1, I multiply that number by the length of the list of empty squares, and then I floor it so it's an even number, and that should spit out an integer of which array position in the empty list I want to use. So then what I would do is that I would say that empty list chosen move, wait, am I doing this right? Empty list chosen move would spit back the board array position that I want to change, right? I think. Empty list, chosen move. It's choosing a move out of the empty list, which is some number between 0 and 8 of the array position of the board where it wants to affect it. So basically this would then be part of board equals 1, and then when it is, then we need to like update board. So let's assume there's a function called update board. This updates the physical board. So it actually changed the fucking variable that's outside the scope of this, which means that this is now updated. Update board simply means that it needs to update the board. So what it has to do is that it has to do board 0 applies to what is it, cell 1, right? And it's sort of like for each one it has to maybe I need to do like 4. I just do the same for loop kind of, maybe, where I'm like, or do I have to have a separate update board function? Couldn't I just update it right here, or like in the midst of doing this, or let's think about this. So I want to update the physical board with the decision that has been made, right? It's sort of like I have the data here. It's like console log board. You can see the updated board right there. It shows a move. It shows, like, you could say, chose to put a 1 at board position boom, right? Yeah, so wait, this is gonna no, this is gonna spit back. This doesn't give you the position though. This is not the position, this is the actual board value, right? Yeah, board whatever. It's just gonna spit back the value of the board. This is gonna say just put a 1 at board position 1, but it's not position 1. It's position empty list chosen move. There we go. And I could even make it more legible by saying cell and then add a 1 to this because of the array being 1 over, right? Plus 1, something like this. Wait, hold on. What the fuck did I do? No, this is fine. There we go. So I could literally do this then to update the board, right? So instead of this update board function, I could just do cell plus empty board chosen move plus 1. This is the fucking selector, and then I do .html, and then we do, what did we call it? Rand move. So then we do span class equals rand move O or something, or X, whatever, slash span. And now it's no longer empty, but we've already updated it, it works. I think that's correct. Alright, let's see if this works. Right? Okay. Syntax error, missing close parenthesis after argument list on line 20. Oh, I see. Okay. Unexpected token line 24, close parenthesis. Wait, really? Oh, I fucked up somewhere. What did I do? Line 24, close parenthesis. Oh, what did I do? Oh, did I? No. Oh, I forgot to do this. Oh, this oh, I abandoned this code up here. We're getting rid of this code. There we go. Yeah, okay. Okay, does it work? Holy fuck. Oh no! Put a 1 at board position cell, not a number. Wait, how did that happen? Okay, so it almost works. So again, it's showing the right shit in the console log. However, not a number. It like breaks when it goes to the last position. So there's some like off by 1 shit happening. Put a 1 at board position cell nan. Undefined 1. Like what the fuck? Okay, so what did we fuck up? Did I do this math dot floor shit wrong? Okay, actually let's think about this. Math random, if we're flooring it, it should always give you a 0, right? So if the length is 2, wait, what do we do? Chosen move equals, let's say there's one move left, and it's a 9, so like empty list length is 1, so it's math random times 1, so it doesn't change, so it's math random, math floor, chosen move equals 0, and then empty list 0 equals, empty list 0 should equal 9 then, right? Or 8, whatever. I is less than 8. Maybe it should be I is less than or equal to 8, because maybe the empty list is not getting less than or equal to 8. Is that right? That might have been a problem. Okay, let's try that. All right. Oh, hell yeah. So now it works, but it breaks when all the moves are filled up. So it works. You can see it working. Right. So we got the random moves. So basically it needs to detect draw or like whatever. Like basically if empty list length equals 0, it shouldn't even allow you to click, like it should. Yeah, I don't know. There needs to be like basically game over detection. Fuck, I'm so lazy, fuck. I feel so fucking lazy. It's like, okay, what's the next step? Now the next step is we need to make sure that you can't try to move when the game, it needs to detect victory conditions. Basically the basic tic-tac-toe code needs to work, so. Alright, tell you what, first we'll do this check right here where it's like if empty list dot length is less than 1, then console.log there are no moves to make, else do everything. Alright, so that prevents that at least. And then we also need to make sure that once a move happens, it's updating, right? It needs to detect a victory, right? So we need to detect victory. Detect victory. So let's have a function called function detect victory. So what do we do? Well, we have board. We need to detect if there's a tic-tac-toe. I'm just gonna probably hard code the conditions of victory. I think I'll just hard code it. Like what's the easiest way to do this? This is the most fun part, is it? Is it really? Okay, wait, hold on. Okay, so I'm thinking about this giant if table now. It's like you can imagine something like if. Oh, it's such a fucking mess. God damn it. Fuck. Yeah, it could be a fucking mess. Detecting victory, fuck. If 1 equals 2 equals 3, or 1 equals 4 is 7, or 1 equals 5 is 9. Yeah. But also, they have to be non-zero, too. God damn it. This is a fucking pain. It's a pain. Wait a minute. If we're checking win after each move, we don't need to recheck shit. We just need to check if the latest move caused a win condition. So we can start at the latest move by passing it in, right? So basically, empty list chosen move. God, I'm confused. Son of a bitch. So what is empty list chosen move? It's board position, right? Board pause equals empty list chosen move. Okay? board pause at board pause +1, right? Empty list chosen move becomes board position. Then detect victory board position. So now board position gets passed in. I guess that's true, Jolene. That you could make that as well, but basically I only have to check from the board position that was placed. So basically a move was placed. You know it's not 0. So basically you do if board position equals, well actually we need to see what it is. Well, I guess there's different checks for different positions, right? So it's like you well, it only needs to detect diagonally if it's on one of the diagonals, right? So it's like I need to like somehow differentiate. Well, in every single case, you want to account for horizontal and vertical victories in every single position. It is only if the board position is 1, 3, 5, 7, or 9 that you have to check for diagonal victories. Right? This is fucking annoying. God. Yeah, this fucking sucks. This fucking sucks. Should I just have separate code for every single board position then? There's 9 of them. Where's this switch statement examples? JavaScript switch. Switch expression, case n, code block break, case n, code block break, default code block. Okay, let's just do that. Switch board position. I'm gonna say board position +1, just so I have it's a little easier for my poor little brain. This is a fucking mess. Holy shit. Alright, so in the case of 1, you need to do a couple checks. So you do if I'm just gonna wait. Fuck. Should I do this +1 shit? Maybe not. I'm just gonna. I think that was a mistake. I just have to remember that it's off by 1, which is kind of annoying. Alright, so if it's the same at board 1 and board position equals board 2, then okay, so that's one win condition, right? But there's multiple win conditions. So we got... Okay, this should almost be a function or something. There should be a function called winner or something. And the function should be like... Right. So we want to check 1 and 2 is like 2 and 3. 3, 4, so 3, 4, 5, 6. That's vertical. And then 0, 1, 2, 3, 4. So then you do 4 and 8, right? 8, 0, 1, 2, 3, 4, 5, 6, 7, 8. That's diagonal. So it's horizontal, diagonal, and then horizontal, vertical, and diagonal. Done. Done! Right? And this can be else if, actually. Right? So basically this is the blueprint of how to do this for, and we just gotta repeat this a bunch of times. So then for case 1, you want to check 0 and 2. And you also want to check vertical. Only vertical. So that would be 0, 1, 2, 3, 4, 5, 6, 7. And that's it. Because there's no diagonal check for that one. And then now we're going to the other corner. Okay, so you want to check 0 and 1 because you're going horizontally. Then you want to check 0, 1, 2, 3, 4, 5, 6. So 4 and 6. And then for the vertical one, you want to do 0, 1, 2, 3, 4, 5, 6, 7, 8. So that's that. All right. So case 3. So 0, 1, 2, 3, you want to check 0, 3, and what, 6? 6, I believe? Because 6, 7, 8, yes, 6, okay. And you also want to check horizontally. So 0, 1, 2, 3, 0, 1, 2, 3, 4, 5. So 4 and 5. And that's it. You don't need the third check. Okay. Now we want to check case 4. Oh, this is the middle square, right? So 0, 1, 2, 3, 4. Now there's a lot going on here. So let's do horizontally. So 4, so 3 and 5. You want to check 3 and 5 as a horizontal victory condition. Right? And then you want to check vertical. So 0, 1, 2, 3, 4, 5, 6, 7. So 1 and 7. And then there's 2 diagonals actually. So this is actually the longest check out of all of them. So then we have the diagonals. So we have 0, 4, and 8. 0 and 8. And then the other diagonal, 0, 1, 2, 3, 4, 5, 6. 2 and 6. Alright. Okay, case 5 should be similar to case 3, right? So case 5, so we have the vertical is 2 and 8, right? And then we got the horizontal, which is 0, 1, 2, 3, 4. So 3 and 4. Right? And then case 6, we want to get 3 checks for that one. Right? So we got 0, 1, 2, 3, 4, 5, 6. So we got 3 checks. So we got the vertical is 0 and 3. And then we have 7 and 8 for the horizontal. And we also have the diagonal. So we got 4 and 2. Okay. Case 7. So this is 4 and 1, and then the bottom row, which is 6 and 8. And finally, case 8, 3-parter, and case 8. You got 0 and 4 is the diagonal. You got 6 and 7 as the bottom. And you also have 2, 3, 4, 5, 2 and 5. Alright, done. Done. We did it. Good job, everybody. Yeah, alright. Upload. Okay. Player 1 wins. Oh, it still lets me do it. Okay, wait, hold on. Player 1 wins. Player 1 wins. Player 1 wins. So it works. The code works. The code works. We did it, y'all. We did it, y'all. I could even display it on the page, like right below the table. I could have like a div ID equals message, and then I can just write the HTML of that. Whoops. So when this console log player 1 wins, you just do message.html player 1 wins. And then I guess you would set it so it's like game state equals in progress or game over or something. So then you do like, so player 1 wins, then it's like game state equals game over. And then when you click next, it's like if game state equals game over, then it needs to wipe the board. Then it clears the board, and it also needs to clear the table. I can do that pretty easily by just doing td.html empty, or empty, right? Empty. Empty, I think, is a jQuery function, right? jQuery empty. Remove all child nodes. I think that works fine. I think that works. So then empty list goes through, yeah. So it empties it, and then it does game state equals in progress. There you go. So now, when we run this code, what's going to happen is it's going to start new games when the game is over. Wait, why did it took an extra step to do this? I don't know why. Wait, hold on. No, it didn't that time. It worked that time, wait. Okay. Oh, you know, it doesn't clear it though. So once the game state is back to in progress, it needs to clear the message. So it needs to empty this. It also needs to empty message. There we go. Player 1 wins. Next move. Player 1 wins. 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 It works. Alright, cool. We got a lot of shit done here. I could clean this up a little bit by being like, next can be display inline block, padding 2 pixels, then this could be like a lighter color, like BB or something, and then this could be like border radius, like 3 pixels, and then next hover, you know, background can be like BB or like FF, like DDFF, and this could be like font weight bold, and then we could do like body or like HTML, like Arial sans serif, and like font size 120% or something, and And then this could have a margin bottom 20 pixels, and then table could also table margin bottom 20 pixels. Yeah. This padding didn't work. I don't know why. I guess I fucked that up. Anyway. Yeah. Pretty cool, huh? Wait, hold on. I didn't get the... You can't see the thing. This thing. Yep. Wait, sans serif Arial didn't even work. How come this didn't work? Is it font face? Wait. Oh my god. CSS font face. That was at font face. No. No, wait. What's it called? Font. CSS font. God damn it. Font family. That's it. Fuck. Font family. Family. Now what happened to my fucking padding? Oh, 2 pixels. Let's do like 5 pixels. That's probably why it's so fucked. And this could probably be a bit better. We need like 7, and then like BB, probably better. And there probably doesn't need to be so much red in there. Like this could be like DD. There we go. That's better. That should be better, right? Yay. Right? And we could put the X's in the middle of the fucking thing too. We could be like what's the easiest way to do this? This is a span. Let's see. Span style equals what's it called? Oh, what's it called? Fuck. Center font. Text align center. Right. Does that work for this? Span style equals text align center. Does that work? No, it doesn't. It does not work. Display inline block margin 0 auto, please. The style equals display inline block margin 0 auto. Does that work? No, it doesn't. Why doesn't it work? Display block, not inline block. No, it didn't work either. It doesn't matter. This is just some stupid graphic bullshit. This is irrelevant for the task at hand, really. It's kind of hilarious, though. Okay, with 50 pixels. How come it's not doing anything? Display block with 50 pixels, margin 0 auto. Text align center. How come it's not doing anything? I'm losing my fucking mind. Holy fuck. How come I can't put the X in the middle of the square? This is insane. I'm trying to align it. It doesn't align. It's not working. I hate CSS sometimes. It's always been like this. Just this fucking pain. Whatever, it doesn't matter. Holy shit. I'm not, line height doesn't matter so much because I'm trying to horizontally align it. The vertical alignment, it's actually already vertically aligned because of the table, I guess. But it's like not, I can't align it in the middle of the square, please. Why won't it do it? Honestly, I could do like TD span, margin left, like 18 pixels. It's so hacky and shitty. It's so shitty. But let's see if it works. Does it work? It does work. That's so shit. Why can't, okay, whatever. Oh, okay. That's a shitty hacky piece of shit, is what that is. Sorry. Let's try 16 pixels. Yes, I know. It's hard coding the pixel width in here is a pile of shit. It's truly just garbage. This is truly garbage, but it works. And it doesn't matter so much for what we're doing. Okay, so we can detect when someone wins. We can detect who wins. Should I now do alternating moves? Or like, how should I do this? What is our next move? Truly, what is the next move here? Are you proud of the thing that I made? Are you proud of this? Are you proud of me? Are you proud of me for making this? Look up all possible strategies. No. That's the opposite of what we're doing. We're not going to code strategies. Alright, I'll check out Yak's paste bin. I'm curious what this is. We're not supposed to code strategies. We're supposed to make the machine learn how to win by itself. Game state is an array while game is running. Chosen move equals player A game state. Okay, so you pass in game state in a function called player A. So player A is a function. You pass in the game state, and then it returns a move, right? So chosen move equals player A game state. So chosen move is the move. Game state chosen move equals 1, update display. If is end condition, new state. Exit this loop. Player is winning. Return 3. Print 2 is winner. Player B game state, empty space examine game state, return empty space is 0. Is end condition. Well, hold on. This is just kind of some structure stuff. But okay, like we have the win condition checked out. We have the ability to make a move. We have made it so there's only it's a one-player game currently, right? Player 1 just puts X's randomly is what happens when you do a move. And Yeah, we're trying to do AI. And I could, like, basically, what's my next step here? Do I make a second player? Should I keep track of, like, whose turn it is, then display, like, whose turn it is, and also have it all, like, just basically have two random results happening, where it's just placing random blue circles as well as random blue X's. And then I make it so that if it's player X's turn, or like player 2's turn or whatever, then we need to do fucking crazy AI shit, magic. We need to make magic happen then. That's where the real magic is. This is all just some setup bullshit. Like, it's not that, it's not like we did much really. We just basically made a shitty tic-tac-toe kind of that will give random moves in a one-player game. I could make it 2 players. That's something I could do, and have like a list. Let's say whose turn it is. All right, one of the players is just gonna do. Basically, this right here. It's like I click. Currently, it doesn't distinguish which player, so it just runs this code, right? And currently, I have it so it's actually just like rebooting the game if it's over, and then it just finds the list of empty squares and just picks one, doing just randomly picking one. So that's what it's doing right now. Yeah, random move or smart move. Yeah. Am I gonna make it learn against itself? I want it to fight against. Maybe it could fight against. Maybe there could be a human. Oh, I don't know. I thought the first step would be to have it beat random moves, like do better than random moves, basically. But then it's like you'd almost want whatever it learns how to play, like you'd almost want it to be able to fight itself. Yeah, I don't know. I think we're still not done structuring this. Like, there needs to be like turn equals 1, right? Like player, like whose turn equals 1, and then if whose turn equals 1, then this empty list shit, right? All of this, then all of this, right? However, if whose turn equals 2, okay, so after it detects victory, actually, here's a question. At the end of the switch... Okay, well, here's a question. So it goes to winner, but I actually don't know how switch works that well. Like, if a winner was not detected, if no winner... Ah, fuck. I could literally just set winner to... okay, wait, hold on. So I could just do like var winner equals 0. And then do winner equals winner equals board position, because that's like whose move it was, right? And then, or even just whose turn. The variable whose turn could work as well. So this winner function here, this could all be removed. Basically, like, it does the whole switch. After the switch, winner is either set to 0, 1, or 2. And basically, if winner is not equal to, if winner is not equal to 0, then winner. Okay, this is confusing because I have a function called winner and I have a variable called winner. What should I call it? Is winner equals 0. Okay. And then instead of winner equals winner board position or whatever, this can simply be is winner equals whose turn. It's so confusing, but basically I'm setting whoever's turn it is the winner now. So there's a winner. Or instead of whose turn, I could also use board position because that would be the same. That'd be the same variable. It's like the same fucking number. I could do a search and replace for this, but I'm already fucking doing this, so fuck it. Okay, so now it sets a variable. If one of these if statements comes true, is winner becomes whoever's turn it was, and then if is winner is not equal to 0, then winner whose turn, or is winner, right? This code is so unreadable, it's shitty. But anyway, so if it's not 0, else whose turn, if whose turn equals 1, then whose turn equals 2, else if whose turn equals 2, whose turn equals 1. So it changes whose turn it is. Or actually, this doesn't even need to be a function now, because I can actually just keep this in the detect victory function and make it less confusing. So instead of winner is winner, just be like player is winner wins. Game state equals game over. And now we're not calling a function, and it's all just self-contained in this function. That's better. And this doesn't even need to be else if, because there's only two different things. So like if it's 1, set it to 2, else whose turn equals 1, right? And I could have a display somewhere that says whoever's turn it is. It could be actually this message thing, right? Well, I don't know if I'll do that right now, but alright, so this is if whose turn equals 1, do this. Else. Now this is the smart AI shit here. Or yeah, maybe player 2 should be the smart one, I don't know. But we're actually going to we're actually just gonna copy this same fucking code. Oh, what is this? Else if whose turn equals 2. What is this shit? No. There we go, right? And this should never happen, so there shouldn't even be an if. This should never happen, so it doesn't even need to be in a fucking if statement. Now this is the smart AI shit, but we're just gonna paste what was already there. Because we're starting with just random shit. So we're just gonna still grab random shit. We're gonna make O as the AI move. And we're gonna use 2 as the board position, you know, set it to 2. Put 2, right? And that should do it. So now we should have 2 different players that are both random. I think so. Let's try it. Oh, we haven't considered a draw, right? So, okay, so in the case of a draw, I forgot to account for draws. It's not default switch case, it's because it's gonna be with 0 through 8 in terms of which move it is, but there could be no winner. But it also needs to check if, basically, in the detect victory function, it goes through all of this. If there's no winner, it shouldn't immediately assume that it should be another person's turn. We need to detect draw. So basically we need to go for var I is equal to 0, I is less than or equal to 8, I plus plus, and then you do if you'll do like var fail like draw equals 0, and then you do, or draw equals false, then you do, well actually this goes outside of the for loop. Draw is false, then you do if, no wait. No, you actually start with draw equals true. And then you detect to see if board I equals 0 anywhere, any of the positions. Because you're checking every single, this could be I, yeah, okay. If board I equals 0, then it's an empty space, then draw equals false. So you go through all 8, and then if draw, then game has, and then you do like message .html, game is draw a draw. Then you do like game state equals game over. And then else you increment, you change whose turn it was. And there you go. Now we have draw detection. The game is a draw. The game is a draw. Wait a minute. Player 2 got to go first. Player 2 is going first. I guess it just remembers who went last. Or wait, is player 2 going first every time? The fuck? Player 2 wins. Player 2. Wait, what? Oh, fuck. It didn't detect a victory horizontally across the middle. Wait, what? Okay, what the fuck just happened? So case 4. If it equals board 5 and board 3. That should work. Wait, what the fuck happened? Wait, what happened? My code is fucked. Something's fucked. Player 1 wins, okay. Player 1 is moving first. Player 1 wins, player 1 moved first. Player 1 wins, player 1 moved first. Player 2 wins, player 2 moved first. Player 1 wins, player 1 moved first. The game is a draw, player 1 moved first. Player 2 wins, player 2 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 moved first. Player 1 wins, player 1 moved first. Player 2 wins, player 2 moved first. I see. Player 2 wins. Wait, I swear to God, it didn't. There was some failure somewhere in there. Like the last time. It like didn't detect a victory in the middle. It's really weird. I don't know how that happened. Maybe I should make it player 1's turn at the start of every I'll just set whose turn to 1 at the start of every new game. I think that's fine. I know it's not fair, but just also I don't know. I feel like there's something weird where it didn't detect a victory when it should have. Okay, case 3. If it's board 4 or board 5, win. If it's case 4, 5 and 3, 3, 4, 5, 4, 5, 3, 5. Oh, wait a minute. 0, 1, 2, 3, 4, 5. So it'd be 4, 3. This says 2, 3. That's the problem. This is wrong. This is fucking wrong. Case 5. It should be 4 and 3. 4 and 3. And then 2 and 8. Yeah, okay. I had a typo in there. That's fine. That's why it got fucked. Okay. Alright, it's always player 1's turn first. And it's fucking working. It's fucking working. And statistically, player 1 should win more often. Because player 1 gets the first move, so it should be more rare for player 2 to win. Because turn-based games are unfair when someone gets to go first. But it works. The code works. Okay, it's all working, and we got the random agents able to play. It's all working. The only thing now is we need to create a fucking machine that can learn. So we have the basis here. We have the basis. We have the basis, but now how do we teach it to... No, we're not gonna program strategic outcomes. We need to train it to learn. It needs to learn how to win by itself somehow. But we need to give it enough. We need to give it a brain. we have to give it a brain. It needs to learn how to win. And this is where I think I sit here and I go, not sure what to say now. A method of statistical learning. Okay, so let's think about this, right? It's sort of like you're only getting the reward signal if you like. Okay, so basically we could hard code the reward signal as win equals +1 point, draw equals +0.5 points, and loss equals 0 points, or -1, 0, and 1 or something, right? Basically, you're trying to maximize. You want to always get the high number, but it needs to have, yes, it needs a memory. It needs a memory of the game. Like, it needs to know. It needs to basically get the data of what happened throughout the game. It needs to know. It needs to know. Maybe it needs like an array of the board for every turn, along with its final result or something. Wait, let me think. Maybe it just needs a list of moves. Maybe it just needs a list of moves. Maybe it needs a list of moves for each turn. Maybe it needs a list of moves and also the reward signal. Yeah, I don't even want to watch it. Hold on, let me think. It's like it needs a list of what happened in the game, and it also needs the result of the game. So it needs the list of every move that happened and the result of the game. But what does it do with that information? I don't know. It needs to do some kind of like black magic. It needs to do some kind of black magic to pattern match the results of the games to the reward over time. It needs to do some kind of pattern matching. So a small hint. Wait. It needs to do some kind of black magic. Fuck. This is hard. It needs to do some kind of black magic. It needs to have some witchcraft. How does it do the witchcraft? It can get the data of the result of the game. It has the result of the game. It gets the result. Win, loss, or draw. 3 outcomes. And it also needs to be able to see what happened in the game. So it needs to kind of like a list of moves, or like kind of what happened in the game. Like what happened. Here is a list of moves in the game, and here's the result of the game. And it needs to do some kind of like magical high dimensional like gradient descent shit, magic black box machine learning to understand how to shape its moves and inputs to get a higher win rate. And we need to figure out how to do that. How the fuck do you do that? This is tough. This is fucking hard. Okay, so this is where we need to make it happen. So instead of this empty list shit, instead of random shit, chosen moves. Like this needs to be basically, it needs to, okay, from any position, it needs to be able to, first of all, take in the board, the current board. From, yeah, it needs to take in the current board. And basically, it's sort of like you have, well, hold on. So it's sort of like you have, like, wait. It's sort of like you have the board, you have like analyze board, and then function analyze return move, and this is the fucking mystery. This is the mystery right here. This is it. This is it right here. It's like so the board it's like you want it to have like a memory though, like outside. It's almost like the agent itself. You don't just get the board and then run some code. It's like you also have like the agent itself has some kind of like there's gonna be different agents that do it differently, right? And some of them are better than others. They're more efficient at winning. And there's something that makes that agent make these decisions, and it can't be this hand-coded bullshit. It cannot be hand-coded solutions to tic-tac-toe. It has to be learning from trial and error and understanding. It's like you need a memory of what happened. It's sort of like you're receiving the board as input, which is going to be this like nine numbers between. It's like it's going to be something like 0, 1, 0, 0, 0, 0, 1, 0, 2 or something. It's like it's gonna receive this. This is what it receives. It receives this and has to analyze it. It's like board equals. This is board, and now what the fuck? It takes this in, and then it also has its own, like, there's something else that it has, like the AI has like some kind of fuck. You know, all this neural net's weights and parameters and hyperparameters and high dimensional space and everything and yeah, fuck. Am I sure I want to remember the list of moves? I want to, well, okay, look, it's like you could show an AI a certain board position. You can basically have this, right? You analyze board, return move, right? I think this makes sense. I think it makes sense. You analyze board, return move, right? It sends in the board. Here's the board, right? So it's sort of like you don't need a list of previous moves. You just need the current state of the system. But in order to make the decision of what to return, in order to decide what to return, this is not hard coded. I mean, like, there's some other, like, there's the bot's, like, essence, or like all the learned stuff. And when you start, though, it doesn't know anything. Like, when you first get a board back, when you first get this back, it's like you don't know what the fuck to do, so you just return a move, and then eventually you get a fucking result back, and then you get the result along with basically maybe what you want is here's what you want. You want the bot to know, after you get the result back, it's like you want the bot to know that, like, the input or the move was, like, say, like 4, yeah, 4 or something, right? It's like you kind of pair these two things together for each turn. So it's sort of like, okay, so like if we had a whole game, for example. Okay, so like let's say we have a game. So we got like 0 0 0 0 0 0 0 0 0 0 0. So this is like turn 1, and then you got like, well, actually there's some shitty fucking random AI doing shit like this. And then you gotta move 3 or something, right? And then, so that this is like one pairing, and then you have another pairing that's like 0 1 2 3, and then the bot went like this. Then the move, so then here's another situation, and then you're just like 0 because you don't know what the fuck you're doing, right? And then here's another situation where you put down the 2 in position 0, the bot, so the bot, let's say the bot did this by chance, right? Result loss or something, right? So here is an example of a full game. Game equals, like, it's an object that has like turn 0 is a fucking object that contains board and move, right? And then you got turn 1 is like a fucking, or like, I don't know, it could just be like 0 1. It could be a fucking array, it doesn't need to be an object. So basically just a list of objects then. So you'd have basically this then would be so then there's this. And then actually what you'd have, oh, I copied the same thing twice. So, and then result should be actually like, maybe this could be like result loss, right? Result like a loss, or like 0. Lost the game, or like -1 or something, I don't know, whatever. And then result, and then history is this array of moves, something like this maybe. Yeah, something like this, maybe. I don't know if I structured this right, because it has a move attached to this, which is kind of weird, because then you get like a final state back, but then you don't get to move. It's a little weird, but so here you have a game. So the game is an object. The game has a result and a history, and then it has your choices. It has the inputs. It has the state that you were in and the move you chose. So this should actually be like a, if this is an object, then this should just be like a thing like this, right? This is like an array, right? There. So this is like, so here we have like, this is like what you get back after you play a game. Like this is what the bot has to work with, right? So this is the fucking data the bot gets to try to learn how to win. These are the decisions the bot made. This is like the world that the bot had to deal with, the state of the game. This is like the state that it was given. This is the choice made. This is the state given. This is the choice made. This is the state given, and the result is you lost. And yeah, so this is like what happened, but the bot then needs to take this result. This is a loss, which means that this was bad. These were bad decisions, or somewhere went bad, like somewhere it was not good. And so like it's sort of like the bot, I don't know, it's like, yeah, fuck, it's tough. It's hard. So like, yeah, I don't know. How did the bot choose the move? That's the thing. It's like when you, well, okay, you can assume it would make random moves to start with. Basically, okay, wait, hold on. So, okay, wait, hold on. So it has to decide something, right? So the bot receives a board. It doesn't know shit about anything. But it has a list, though, of possible moves. So it could do what the other bot did, which is have this list of possible moves, and then this line right here gives them all equal random weights of like which move is good. And this is kind of how it would kind of start, I guess, for the bot, where it would kind of, they would all be equal weights. You would not have any idea of what's a good move or what's not a good move. But, when you start getting this back, this is like feedback. And somehow using this feedback, these are no longer supposed to be random. It's supposed to somehow take this data and like sort of weigh moves differently depending on the situation somehow, and that's like the magic of it. That's like the magic. Well, you can construct the board out of the moves, or you could just give it the board. It doesn't particularly matter too much, I think. So each move would have a value then. The bot should have some kind of like, the bot should kind of have like a number between 0 and 1 over like what it feels is a good move, kind of, and it should just go for the moves that feel the best. but the way those numbers get solved is basically, like, it needs to use this data to start to construct its understanding of how to value different moves. How does the bot decide, what moves does the bot value? It has to use this data to try to understand how to value moves. Well, it's like the last time this happened. Yeah, it's like, yeah, I agree, Yak, and that's why I'd want to pass in the board and not just the move history. Damn, this is where it gets like so fucking hard. This is where it gets really fucking hard. Start at the beginning. Well, I almost wish I could draw. Like, I feel like I need to be able to draw. I don't know, I guess I could still just write things down, but yeah, it's like okay, like what are all the possible like boards you're dealing with, right? Holy shit, yeah. This is just the first turn, right? And I'm just gonna get rid of this first example because this is for player 1. The bot's always gonna be player 2. After the first turn, here's the different outcomes, you know? It's like, this is just the first, this is the first state that gets encountered. Whoops. Yeah, this, like, the bot will receive one of these states as the first state. But there's so many possibilities that it just quickly explodes, you know, and yeah, it's like you can't program into the bot that like the middle square has like 4 different win conditions, or that if someone moves here, like moving on this tile would not block any of their path to victory or anything, you know? You don't want to pre-program any of it. You simply give the bot states, and then the bot makes decisions, and then there's an outcome at the end. And then the outcome and the decisions made shape the bot's decision making somehow. Nine-digit base 3. So basically, are you saying the whole game state could just be one number? Is that what you're saying? Here's a number representing the game state. Now, spit back a decision. Analyze the number and spit back a decision. That's what you're saying. So okay, wait. So yeah. Now keep in mind, like, let's say this is the state, right? Let's say this is the state. It's like, if this is the state, this is the input, right? If this is the input, then like, this is the input, then possible outputs, like, basically, you receive an input, then there's like a list of possible outputs, and then the bot actually needs, what the bot has to do is it has to like, you know, it has to like basically set values for each of these, like, something like this, right? This is basically what needs to happen. So basically, then it becomes, how do you get these numbers? Like, where do these numbers come from exactly? You feed this number into a bot. The bot spits out wait, no, hold on. You feed this number in along with these potentials, and the bot's job is to weigh the potentials as to which one it likes the best. Now, how does it get these numbers? That's the fucking hard part. That is the thing we have to figure out then. MSC? Sorry, what? Oh, okay. The thing is, the bot needs to be able to take any possible one of these 19,000 different inputs, and given the possible outputs, it needs to be able to weigh them for any of those thousands of possible things. Well, yeah, since you're starting from scratch, they should all be from the beginning. They should be like either randomly set to like random values, or they should all be the same value or something. So one of the two. Oh, rotated boards. Yeah. That narrows it down a lot. Like mirrors and rotations. Yeah. Okay, so each of the... Wait. When you say 19,000, where's exactly does the 19,000? Oh, by 9. 19,000 by 9. Well, by 9? Because, like, sometimes you don't have this many moves. Like, notice this is only 8 moves. You see this? It's not 9 moves. There's only 8 blank spaces left. So, for some things, there could only be like 2 moves. Yes, you would want the bot to learn about the symmetry and not program that in. I agree. The bot should discover the symmetry. So what do you want then? Do you want, basically you're saying make this giant data set that basically has any possible input and all possible outputs from that input, and then they all have some amount of beads in there, and basically if you lose the game you take away beads from that input output thing. And it's possible though that you lose a game where you made a really good move. So you lose a game, you made a really good move in a game, but you lost the game. Do you still take beads out for that one move that you made where you lost the game? I guess you could, because you would still win with higher probability in games with that good move, which should probably make it a more viable move. So even though there could be times where a good move resulted in a bad game, that was the result of other bad moves and not the good move that you made, right? Is it this simple? Did we just figure it out? You basically have a huge fucking... But like I said though, it feels kind of like hard coding it a little bit too much, because for example, the symmetry, for example, like how is the bot gonna learn anything about the symmetry of certain positions if you just give the symmetry's different drawers at all. How would the bot learn the symmetry and know that certain positions are identical? And like collapse. How would the bot be able to collapse once it realizes there's symmetry? It's done outside the weight storing. Could you elaborate on that? What do you mean? If you have a different drawer for every position, and some of those positions are mathematically identical, how does the bot fucking learn that and actually consider that? How does the bot end up considering them the same thing? The bot would have to like be able to the bot would have to learn that they're the same thing. What do you mean you check if there are symmetries? What do you mean by that? What do you mean you check? You say there's only one drawer for one set of symmetrical outcomes. But how does the bot narrow that down? How does the bot make only one drawer for the symmetrical position? How does the bot learn about flipping and rotation? How does the bot learn this? After all, if a move goes in the bottom right corner, why would the bot... How does the bot learn that the corner is the corner? How does the bot learn that? You write code to reduce the symmetrical position, so you hard code it. The bot doesn't get to learn this though. The bot has to learn this. The bot doesn't know anything about symmetry. But I want the bot to reason that it is symmetrical, and then the bot can collapse it down. The bot itself can, not me. I don't want to program like mirroring and flipping the board into the bot. I want the bot to reason that by itself. But what is reason? Well, yeah, exactly. What is reason? Okay, listen, the bot needs to. Maybe this bot starts and it doesn't understand flipping and mirroring and symmetrical positions. It doesn't understand that. And then the bot plays a fuck ton of games. The bot needs to learn that and reason that those are identical positions. And in the bot's internalized model of how tic-tac-toe works, it needs to understand that those are symmetrical positions. And I can't teach it that. It needs to learn that through the act of play. Have a probability for this being a mirroring of another position? What do you mean? A probability for this being a mirroring. You'd have to write that separate learning thing? See, I don't know. This feels so limited. Like, the bot needs to. It needs to learn. It needs to learn. It's machine learning. It needs to learn. It needs to not just adjust parameters based on results. It needs to learn that this position is symmetrical to this position. It needs to learn that. Otherwise, its internalized model of tic-tac-toe is like kind of shitty. If it considers them separate, like it needs to know, like, if it's trying to play optimally. It's a separate task. Is this a mirrored position, a rotated position, or is it unique? You say it's a separate task, but it is related to the act of winning at tic-tac-toe. Don't you think it's related to the task at hand? The internalized model of tic-tac-toe is shitty, and it doesn't know shit about rotation. It just knows that if there's an X there and an O there, then I play there. But shouldn't the bot learn that this position is identical to this position? X position is identical to Y position. It's just like rotated. In my opinion, if it can't learn that one position is rotated or flipped, if it can't learn that those are identical positions, if it has an internalized model of tic-tac-toe that does not consider those identical positions, then it has failed at understanding tic-tac-toe. A table of weights. That's what neurons are for. Okay, tell me about neurons then. It will learn that when it gives those positions identical values. But Juna, if we're only adjusting the weights based on results, right? If we're just adjusting the weights based on results, and it's just like, it kind of, it ends up like moving towards being identical, right? The two positions. After enough time, it'll move towards it, right? But the bot has no reasoning capability to make that conclusion. And that is a flaw. That is a flaw. I believe that if the bot is trying to understand tic-tac-toe, and it doesn't internally consider a move in the corner, regardless of corner, like if the first move is in the corner, just like what's on screen right now. Listen, if the screen right now, the board right now, if it was a different board and the X is in any other corner, if the bot doesn't mathematically consider those identical positions, then the bot has failed at understanding tic-tac-toe. The bot has failed. Why has it failed? Because it doesn't have the correct mathematical model of how tic-tac-toe works. Sure, it may win, but it's not accurate. It's not accurate. It considers it different. There's like noise. There's noise. It's imperfect. Its model of the position has noise in it. The noise, it's not smart enough to get rid of the noise in the position. Okay, fuck fooling a human. We're trying to make a machine human, right? We're trying to make a machine have the reasoning and understand this. Alice, this is like hard coding it though. Now we're hard coding it, right? And we don't want to hard code it, right? This is next level shit I'm talking about. I'm on this. I'm fucking on this. I'm saying, like, if you teach this bot how to play tic-tac-toe really well, and it considers those 4 corners to have slightly different, very slightly different, if it considers it slightly different positions, then it's merely kind of converging towards an accurate result, but it never reasoned that those positions are identical. So its internal model of what tic-tac-toe is has noise in it, and the bot is not smart enough to remove the noise. So you haven't succeeded at making an intelligent being. It's not intelligent. It's simply converging towards some result. It's not good enough. It's not smart enough to understand what tic-tac-toe really is. But Yak, you know that if someone moves in a different corner, that is an identical position. You know it's mathematically identical. You know it's a rotation. You understand this. You understand this. You're saying the bot does not understand this. It does not understand. It's not smart enough. It doesn't understand. What is understand? Exactly. Exactly. It understands enough to play where it needs to play to win. Then maybe, you know what, maybe tic-tac-toe is not a smart enough game then for what I'm trying to accomplish. Because if the bot can't understand that the first move in a corner, any corner is mathematically the same move. If it can't completely understand that those are identical moves, then its internalized model of tic-tac-toe is noisy and shitty, and it's not crystal clear. It's not truth. Maybe we need a different game. Maybe tic-tac-toe is not good enough. Well, shit. I don't even know what to do now. I don't even know what to do now. There's a Fields medal in it for if you can write a bot to do math. Writing a bot to do math. Is that what it is? You're writing a bot to do math? You're right. Okay, so the bot, basically the bot would have to prove, the bot would have to prove on its own through play that 2 positions are identical without being told to do so. It needs to kind of come to that. It needs to come to that point. Like, once it starts getting enough data and it starts converging on the truth, it needs to have the fucking insight to see the truth. It needs to be able to see the truth and know that those positions are identical. Not yet, Yak, but that's what this fucking stream is about, right? You're saying it doesn't matter because it can still win at the game, but you're kind of missing the point. You're missing the point. Okay, how can it prove? How can it prove that two positions are identical? How can it prove that? How can it prove that two positions are identical? How can I prove it? That's a good question. I don't know. How do you prove it? How does one prove that two positions are identical in tic-tac-toe? This is a good question. Oh, you don't know how to do it either. Okay. Yeah, I don't know. I mean, we know it's true, though. We know it's true. Right? It seems like very obvious that it's true. Why? Why is it true? How do we know it's true? You prove it by rotating the board. Well, hold on. Maybe the proof is in the statistics. If the weights converge, maybe they're equal. Okay, Yak, but the weights may never totally converge, will they? Will they ever completely converge? Like, is there noise in it? Like, couldn't you have a situation where you play like a million games and the noise is like slightly different between each game? Or between each identical rotation? And because the noise is different, you can't prove it's the same position, or does it like it figures out how to play the game in the same position given two different flipboards. By experience, it figures out how to play. See, it's possible that like maybe the weights end up being a bit different, but like the like one move is clearly the best or something, or like, well, you say it's because of floating point errors, but not necessarily though. Like, couldn't you say that in one corner it just happened to have better odds of winning when it played a certain position because of noise, because of randomness, because it only played so many games and it only has so much data to build its fucking model of tic-tac-toe out of, right? Sure, we learn by experience, but how do we know it's identical? Well, so what, a human decides that, Yak? A human decides that the threshold is 0.001 in a hard-coded fashion? Is that how we fucking deduce things? Is that how we fucking have insight about truth? I feel like it's not good enough. I'm not satisfied. We use logic. So, yeah, what does the bot have to do then to like? How can the bot know that? How does the bot know those positions are the same? Like, how do we know if you rotate the board, it's the same thing mathematically? How do we know that? How do we know that? You take a board position, you rotate it 90 degrees, you still know it's exactly the same mathematical thing. You know it is. We know this. Like, you know it, I know it, we fucking know it's true. We know it's truthful, we know it's true. How come the bot can't deduce that? How come the bot can't know this? What is preventing the bot from, like, understanding this? What is truth? Would you say that once the board is rotated 90 degrees, it is mathematically equivalent in terms of like, as far as all the strategy and game theory and whatnot, it's exactly the same. Just because it's rotated doesn't mean anything has changed about the position. The position remains the same. It's identical. You can rotate it. You can flip the board too. You could flip the board as well. You can flip the board and rotate it and it's still the same position. Nothing has changed about the position. You know the position is exactly the same. I don't think I'm thinking about it wrong at all. I'm saying this model we have of tic-tac-toe in our heads, where we understand that if we flip the board and rotate the board, it's the same position. We know that's true. How can the bot know this? How does the bot deduce this? How does the bot find that truth? I'm not thinking about this wrong. I'm fucking not. The bot finds it through experience, but how does it know it's the same position though? Because once it does, once it does know it's the same position, it can simplify and optimize its understanding of the game. It can reduce the amount of possibilities because it knows different positions are identical. It can optimize its fucking understanding of tic-tac-toe. Once it understands this, once it understands identical positions that are the same mathematically, it can fucking know this. It can optimize its understanding of tic-tac-toe to be more accurate. Yes, I think I have. I think I'm like on the. I think I'm very happy this stream has happened. I'm very fucking happy this stream exists. I feel very passionate, and I have no regrets. Like, what are we trying to teach the bot? We're trying to teach it tic-tac-toe. Right? How does the bot understand tic-tac-toe? Well, one of the things is that there are positions that are identical via rotation, flipping the board, mirroring the board. They're the same position. But the bot doesn't know this. How can the bot learn this? That it's truly the same position. I'm not kidding. This is so serious. I'm so serious. Okay, how do you do it, Guzco? How do you do it? How does the bot discover isometric transformation? How does the bot discover isometric transformation and find that truth and incorporate that knowledge into its internal understanding of tic-tac-toe? How does the bot achieve this? Humans achieved it. Humans have achieved this. How does the bot achieve this? I want the bot to discover it. I want the bot to discover it. I want the bot to discover it, but if, like, I mean, the statistical means gives, it gives like a, it gives the bot information that kind of signals the truth, but the bot needs to be able to take that signal and it needs to, like, prove, it needs to prove it's true. It needs to prove the isometric transformations give an identical position. It needs to know this. It needs to solve this. It has to get there. It has to get there. It's not good enough. If it can't get that far, then it's just a stupid fucking AI. It's not even smart at all. It's stupid then. So what the fuck is even the point? Oh, it can win at tic-tac-toe. Okay. Who gives a fuck? I don't care. If it can't fucking understand the isometric transformations give identical positions, then it has failed at being intelligent. It has failed. Really, Juna? Do you know more about this? I'm curious about it. They may not be that much more insightful, Yak, but the bot needs to find that isometric transformation symmetry stuff. It needs to find it. It needs to find it and like know it. It needs to. It has to. Otherwise, it's not good enough. That's my fucking opinion on this. I feel so strongly about this. Also, considering the work that OpenAI did on Montezuma's Revenge, that single human demonstration thing, that was not smart intelligence. That was like so dumb. They should fucking like, I should fucking work for OpenAI so I can get all passionate like this. Get up on my fucking soapbox and let them know. Like, let them know what they should be working on. Cause I have the insight. I have the insight. Holy shit. Alright, well, this was a good stream, everyone. I think we got to where we needed to get to. We all need to think on this. We should all take a break and think on this, because holy fuck. We got some, like, there was some insight in this stream, and it was like, it was a good fucking stream. This was fucking beautiful. It was beautiful. This was beautiful. No, it's not wrong. It's not, though. It's not. How is it wrong? How is it wrong? If you're trying to get a bot to understand tic-tac-toe, to understand it, it needs to understand that symmetry. It needs to understand this position is identical to this position. That is like a facet of tic-tac-toe. It has to understand this. It has to. Otherwise, it's not intelligent. It's not understanding the truth of it. It's not understanding the truth of tic-tac-toe. Well, sure, you could write a program that evaluates it, but if you're writing it, then you're not creating AI, right? Yeah, the bot has to uncover the truth. The bot has to discover the truth. How do we make a bot that can discover truth? I disagree. I feel like I feel like I'm so on this. Yeah. That's what I'm saying. We need to make intelligent bots, and I'm like trying to fucking get us there. What do you mean this is a dead end? What do you mean? No, you're just giving up, Yak. You're fucking giving up. This is what I don't like to see. This is why I'm passionate, because I know I'm on the right track, and we can't give up. We can't just give up and say, we can't just yield and say, oh, you know, there's smart people out there, so our brainstorming is worth nothing. It's like, fuck that. Stop fucking disabling yourself. You have to believe in yourself. The table of weights is the best we have. Fuck the whole table of weights. Fuck that. The bot needs to understand the truth of tic-tac-toe. It needs to understand the truth. These positions are identical. They are 100% identical, and they need to know this. It needs to deduce this. It needs to, like, find the truth. It has to. It has to. What do you mean it's impossible? Yak, you say it's impossible, but humans did it. Humans did it. How the fuck could biological intelligence do it? And you say that an AI can never do it. Are you just giving up that we could ever have intelligent machines, ever? Are you just completely disregarding the idea that we could have intelligent machines someday? You just think it's not doable? How come you think it's undoable? We've already proven it's possible in biological intelligence. Why can't a bot do it? I think a bot could. I think we need to get there and solve it. I think we have to fucking come up with a way to do it. There has to be a way, because our brains do it. Our brains have been able to do it. We've been able to prove these positions are identical. As far as you can tell, statistics also. You know, though, that if the X in that bottom right corner was in the bottom left corner, you know the truth. You know it's a truly identical position. You know it's identical. You know it's identical. In terms of, you know, all the possible moves and outcomes. It's just a rotation. You know it's just a rotation. You know it is a rotation. You know it is only a rotation, and that there's not some difference in it. You know. It's true because there's no evidence to the contrary. You know it's true because it's true. You know it's true because you just know it's true. It is true. It is true. It's truthful. You know it's truthful. You know it's truthful. You know that you could, okay, Yak, you know you could analyze tic-tac-toe for the rest of your life, and you know you'll never find a lack of symmetry there. You know it'll be symmetrical the whole way. You know that you could spend the next 50 years working on this and you'll never ever find anything that shows it's not symmetrical. You know, truthfully, it's symmetrical. You know this is the truth of tic-tac-toe, and I know that if we want to make an intelligent machine that should play tic-tac-toe, that it should actually be able to deduce the truth of tic-tac-toe, what is tic-tac-toe, and it should also be able to deduce that this position is identical and that there will never be a breaking of that symmetry. It needs to know this. It has to know this. Otherwise, we'll never make progress with artificial intelligence. Yak, Yak, I agree with you if the weights become perfectly identical. Like, if there is a perfectly identical. But don't you think it'd be interesting, though, if you could ask about a bot about... If you could... Well, how could you, Damn, this rotation thing just totally, like... Sure, I'm agreeing with what you're saying now, Yak. Now I'm agreeing with what you're saying. If it truly comes to the exact same weights, if it truly doesn't have noise in there, if the weights don't have noise, if it's not like slightly different, if it completely converges to the exact truth of it. So, yeah. If there's a noise in there, though, then it sucks. So where do we... Okay, wait, hold on. I was maybe gonna go for a walk or something after all this, but... We live in a noisy universe, you can't eliminate it. You can't... Look, though, this game, though... This game, this mathematically thing... There's no noise in it, though. There's no noise in the truth of the game, Yak. Yak. The truth of the game. There's no noise. These two positions are identical. You know they are. You know they are. There need not be noise. You know that if the X is in the bottom left corner instead of the bottom right corner, you know there's a perfect symmetry. You know there's a perfect symmetry. You know. And the bot needs to know that too. The bot has to know that. It has to know that. I don't know what you're trying to say, Ray. But Yak. Your brain and my brain are not perfect computers that have calculated tic-tac-toe for an infinite amount of time. We didn't do that. But we know it's symmetrical. We know it's symmetrical. We know it's symmetrical. We know that. You're saying the bot can never know this, and all the computational power in the entire universe can never find the truth of tic-tac-toe. Yeah, we did. We found it. And we know it's true. We know it's true. There is no doubt. There's 0% chance we're wrong. We know it's true. So the bot needs to be able to discover this and have that truth. I'm not too I'm stubborn because I'm stubborn for a reason. I'm stubborn for a reason. I'm stubborn because I'm right about this. I'm stubborn because this is important. I'm stubborn because this is something very important. You know though, Yak, you know if the X is in a different corner, there's a mathematical symmetry between the game states from those two positions. You know it's true. You know it's true. You know it's true. There's not noise in it. There's a truth to it. I'm not wrong. You're wrong. You're fucking wrong. I'm not wrong. You know it's perfectly symmetrical. You know it is. You know it's perfectly symmetrical. Write the program so that the bot can know it's true also. That's what I'm saying is the goal. The bot needs to be able to know this. The bot needs to be able to prove it. The bot needs to be able to prove it. In its current universe, it doesn't know that. That's the problem. That is the problem. It doesn't know that, but it needs to. Otherwise, we're not going to make advancements in artificial intelligence. We have to be able to do this. This is something the bot has to be able to do. It has to be able to know this truth that we know. We know this is true. We know it's truthful. We know it's true, and the bot needs to know it too. The bot needs to be able to fucking know it. I'm not wrong, I'm not wrong, I'm not wrong, I'm not, oh, I'm just wrong, oh, okay, you really showed me there, I'm just wrong, oh, okay, come on, fucking come on. Yak has no real fucking response to me. Just spouting bullshit at me now. Wait, hold on. Guat ta fuck. Listen. You say you should give the bot a better representation of the board, one that's independent of how it's rotated. We don't, though. We give the bot something that is not simplified, but the bot needs to be able to simplify it. The bot has to. The bot has to figure out that it can be simplified and then simplify it. The bot needs to optimize its understanding of the game. If I can come up with a machine, a program that can, given Tic-Tac-Toe, produce a proof that certain states are identical, you'll gladly eat your hat. But can't a human do that though, Yak? Can't a human produce a proof that certain states are identical, right? Surely that's been done before, right? Surely there is a mathematical proof that these states are identical, right? That a human created, right? It's proof of the identical statements, right? Do you agree that a human could do it? Yeah. You agree that a human could produce this proof? You agree that a human could, right? Yak? You agree a human could produce such a proof, but... Okay, so you do! You agree a human could produce it! But you say you'll eat your hat if a fucking machine could do it. And this is the fucking bridge we need to build. This is the path, okay? We need the... You agree a human could produce the proof, but you'll eat your hat if a machine does. Then we need the machines to be able to. We need to figure out, what is it about this? What is it about this puzzle where a human can produce this, but a machine cannot? Where is the lack of understanding there? We need to find it. We need the bot to be able to do it. I agree it's non-trivial. I agree it's hard for the bot to do it. I don't think it's easy for the bot to do it, but the bot needs to be able to do it. It has to be able to do it, and it should be possible in nature. It should be possible in nature for the bot to do it. Because it's all physics, right? It's my fucking brain, right? It's my fucking brain, neurons and shit, right? Why can't the bot do it? It should be able to. There's no reason it shouldn't be able to do it. There should be no reason the bot shouldn't be able to do it. We just The human lives in the universe with infinite space to doodle on and others to talk to and bounce ideas off of. The bot is just in its universe. Okay. This is interesting. Now we're getting interesting, Yak. Finally we're getting interesting. So you're saying the bot is in the system of Tic-Tac-Toe and it can't like analyze Tic-Tac-Toe? It can't look at Tic-Tac-Toe and analyze Tic-Tac-Toe? It can't look at the data it gets back from Tic-Tac-Toe, and then it can't solve the mysteries of Tic-Tac-Toe? It can't find the symmetry in Tic-Tac-Toe? You as a human living in the complete universe can prove Tic-Tac-Toe is whatever. But the Tic-Tac-Toe bot cannot without other resources. Why can't it? Why can't it? Why can't it? Without a system beyond Tic-Tac-Toe, it cannot do anything. What does the bot need to be able to do to reason that these positions are symmetrical and know it's true? What does the bot need to be able to do that? What does the bot need for that? Unless it has the tools of rotation and mirroring, it cannot prove those. It cannot prove something about axioms to base things on. The current axioms it has is that if it plays a thing here, it wins and gets a cookie. What do you mean the tools of rotation and mirroring? The tools. The tools of its universe are extremely limited. That's why you can't believe it can do any better than figure out when to win. Well, listen, if the bot works in the way you say it does, in which there's all these drawers and it adds a point or takes away a point when it wins or whatnot. I'm just saying, we're these humans, we're these intelligent beings, we have consciousness, and we look at this game and we can sense and know and figure out and solve and prove that these two positions are perfectly symmetrical and there's not a break in symmetry between them. How come the bot can't do that? How come the bot can't do it? What does it take to get the bot to be able to do it? What does the bot need to have to be able to do it? What does the bot need to be able to do such a thing? To look at the game Tic-Tac-Toe and know that these two positions are identical. An observation about the game itself. An observation about the truth of the game. Let's say we start playing Tic-Tac-Toe, and for some reason we think the bottom right X is a better place to put the X than the top right. Why? Well, eventually you realize it's the same, right? Eventually you realize that it's the corner is the corner is the corner, right? A mathematical understanding bot, not a tic-tac-toe bot. It's a question of what is mathematics and how does a human do mathematics? And neurology or philosophy isn't there? What are the basic building block neurons involved in doing mathematics? I don't know. I don't know. These are questions. We need to solve the questions. Is it super hot outside? What the fuck is going on? I see, okay. Something about corners. Well, it's kind of like, let's say for this first move, there's sort of like these 4 drawers, right? The drawer for the bottom left, the drawer for the bottom right, the drawer for the upper left, and the drawer for the upper right. But these are all, everything contained in the drawer, everything going down the branching tree of possibilities, all of it, like, they're not 4 different drawers. They're just mirrored, like, I mean, they're different in that they're mirrored, but the positions are like, you can find, like, basically the knowledge that you can find an identical corresponding thing in the one of the other 3 drawers. And sometimes it's more than 3, like sometimes there's like 8 symmetries or whatever, or like 2 symmetries. Well, we're talking about corner moves and like symmetries and rotation. Yeah, I want to create a consciousness. That's right. That's right. Well, sure, Guat, but this was first an examination of tic-tac-toe and then some broader questions. Ray, I think you're like you're just not keeping up with this conversation. I think you just need to chill out. Okay. I'm 65 IQ. I don't think so, Guzco, because my AI would be able to have understanding of symmetrical positions in tic-tac-toe and know that they're identical. Well, the AI that's being proposed would merely converge upon similar weights between the different symmetrical moves and not understand that they're actually mathematically identical, which would have a less optimized understanding of what tic-tac-toe is. So actually what I propose would be better than the AI that others are proposing. Like, people think I'm stupid. Did you see what OpenAI did with Montezuma's Revenge? They took like a fucking input file of a human demonstration and then put the bot right at the end, and then had the bot do random shit until it figured out what was good to do, and then they moved the save state a little bit backwards and had the bot get a little bit further and kept doing that, and then they're like, hey, we made an AI that can play Montezuma's Revenge, but it was such a stupid fucking bot. These motherfuckers don't know anything about artificial intelligence. I should be fucking working for them. Holy fuck. Yeah, what they did doesn't show any intelligence. There's no intelligence in what they were doing. It was so stupid. Fuck. Holy fuck. Yeah, Red, that sums it up actually. I wanted the AI to comprehend the logic behind tic-tac-toe, not just play moves from positions that win, but to understand the logic behind tic-tac-toe. So a deeper understanding. I wanted a deeper understanding of tic-tac-toe. The bot finds the deeper understanding. Like innovation and understanding, like better model of what the truth of the game is, and not just this fucking giant fucking table that fucking tells you what moves are good. No, I want something that understands the truth of it. Everyone's so mad that I have such passion and insight. They can't handle it. They can't fucking handle me. That's okay. I'm used to being misunderstood. But we understand the truth, Yak. Don't we understand the truth? Yeah, fake it till you make it, but listen. I don't want to fake it. I want to get there. You see? That's the difference. You know the truth. You know if that X is in the other corner, that there's a total symmetry between the two positions. And every move thereafter could be rotated or flipped and they would also be identical positions, and you know that's true. And the bot needs to know that too. It needs to be able to know the truth of tic-tac-toe. It must know the truth of it. Oh. Alright. Good stream, y'all. Good stream. We all got a lot of thinking to do. And perhaps tic-tac-toe is not the best trajectory. We gotta come up with different, yeah, we gotta have different, we need different, we need something else. Tic-tac-toe is not gonna cut it. I don't think it's gonna cut it. I mean, I don't know. Actually, I mean, I don't know. I don't know. Damn. I actually don't know what trajectory we go from here. I'm not sure. Everyone's so mad at me. Holy fuck. No, fuck you, Yak. I achieved more in this stream. I achieved a lot in this stream. This was a good stream. This is productive. Come on. It was productive. You know it was productive. You know it was. Because we got to the point where it's like, sure, you can make a bot that plays tic-tac-toe well. It doesn't know shit about it. It doesn't understand tic-tac-toe. It doesn't understand it. It doesn't understand the truth of it. It doesn't understand the truth of it, and it has no way to understand the truth. It's stuck. It's fucking stuck. It's a dead end, and it needs to be better than that. It's not good enough, and I'm not satisfied. Listen, yeah, just think on it, okay? Think on it. And there's probably different scenarios we could use outside of tic-tac-toe that would maybe yield different results that would be interesting. So it doesn't have to be tic-tac-toe. But this was certainly an interesting stream. Very interesting. I'm happy to be a little brat. I'm happy to be the little brat. I will forever be the little brat. I will never stop being the little brat, and I'm loving it. Alright, goodbye. Thank you for watching. What a wonderful stream. Beautiful. Beautiful. Alright. Goodbye.